Hi guys, let's take a moment to talk through some concepts that were introduced in Unit 1 Guided Notes, pages 1 through 3. Okay. So, first thing we talked about was the importance of units and what a ratio is. So let's talk through ratios. And what I like to focus on here is equalities. Okay. So if I have an equality like 5 over 5, an equality is anything that is going to equal 1. Now they don't have to just be values like this, we can throw units in as well. If I have 1 meter and I want to create an equality, then I need to have it matched with something that is the same length, only different units. So we know that 1 meter has 100 centimeters. Okay. And those are two of the same values, so they're an equality. They would equal 1, and we can use them in conversions. Okay. So now that we have this equality and this ratio between these two values, we can use them to convert from one unit to another. So there are 12 inches in 1 foot. How many inches are there in 6 feet? Okay, well if 1 foot contains 12 inches and I have 6 feet, we have our 6 times by 12 is going to give us 72 inches. Okay. We have 72 inches in 1 foot. Okay. Now, 12 donuts in a dozen, and I have 72 donuts. Well, 72 divided by 12 will tell me how many dozen I have, and so I would have 6 dozen. Okay, 4 quarts in a gallon. How many quarts are there in 1.5 gallons? Okay. So I know that each gallon contains 4 quarts, and I have 1.5 gallons. So 1.5 times by 4 gives us 6 quarts. Okay. The next thing we talked about was this algebraic review and manipulation. Okay. So first, let's take a moment to remember, how can I rearrange an equation that has values that are added together or subtracted? So in this one, if I want to solve for x, and I have x plus y equals z, well I want to get x all by itself. So I'm going to minus the value of y to both sides. Because here, y, a positive y minus y is going to equal 0, so those cancel. And we're left with x is equal to z minus y. So here's my final answer, so I'm going to put a box around it. Okay. Now when we look here, you'll see that x minus 24. So now we're doing the opposite. Instead of having an added value, we have a minus value. So we're going to add 24 to both sides of the equation. So then x is going to equal 13 plus the 24. And 13 plus 24 is 37. We box our answer. Okay, I'm going to flip the page. Now the next thing that we covered was multiplication and division. So if we have a value that is multiplied, then we can divide by that same value in order to cancel, but it needs to be done to both sides of the equation. So if I want to get x all by itself, then I'm going to need to divide by k and divide by k. So now the k values cancel. So x is going to equal f divided by k. Put a square around my final answer there. Now if I have multiplied values again, then I want to get x by itself, Again, I'm going to divide by 7 on both sides of the equation. So that leaves x by itself. So x is going to equal 8 divided by 7, or 8/7. Right? Another tool that you can use is cross multiplication. So BA over x is equal to TR over H. We can start by cross multiplying, taking this BA times by H and the x times by TR and setting them equal to each other. So BAH is going to equal TRX. And now we're going to solve for x. And so we'll divide both sides by the TR value. So then that leaves us with BAH over TR is going to equal x. Okay. Now for this one, it's asked us to solve for the second temperature component here. And so we're going to rearrange this equation to solve for T2. So let's cross multiply again. So when we do that, we're going to have pressure 1, volume 1, temperature 1, or sorry, temperature 2, because I'm cross multiplying. So these multiplied with that are going to equal to those multiplied there. So that's going to equal pressure 2, volume 2, temperature 1. And then we're going to get T2 by itself. Everything's multiplied here, so now we need to divide. So we need to divide both sides by pressure 1, volume 1. Okay, so it'll cancel here, and we're left with T2 is going to equal pressure 2, volume 2, temperature 1 divided by pressure 1, volume 1. And then at a later time, I would give you these values. I'd tell you that the pressure is this, the pressure 2 is this, pressure 1 is that, volume 2 and 1, and values there, and then you can solve for T2. Now, what if we're working with powers or exponents, and what do we do? So here's the way that this would work here. We have x to the 5th, and then we have x to the 1, right? And so those values can cancel. This x below can cancel with one of the x's above here, because this is the same thing as x times by x times by x times by x times by x divided by x. And so this x will cancel with one of them. And so then we're left with 4 on top of our fraction. So this would be x to the 4th. We can continue with this idea. We have 4 above and we have 6 below, so 4 of these are going to cancel with 4 of those, so we'll have 2 left over in the bottom of our fraction. Okay? And so we're going to be left with 1 over y squared. Now, here they're multiplying. And when we're multiplying these fractions, we could, if we wanted to, just rewrite it as A3 B6 over B4 A7, and then we see what cancels. So 3 of these A's are going to cancel with 3 of those, leaving us with A to the 4th on the bottom. And then 4 of these B values are going to cancel with 4 of those, leaving us with B squared on top. And our last one. Okay. So when we take this square root of a value and everything's under the square root, the first thing to know is that we can break this up. This is the same thing as the square root of f to the 4th times by the square root of a to the 6th times by the square root of g to the 5th. Okay. And then with exponents, if we have a square root of an exponent, it's dividing the exponent by 2. So this would be the same as f to the 2nd times by a to the third. Now, 5 doesn't easily divide by 2, and we don't want a decimal or a fraction as our exponent, so we'll leave it in the square root. Times by the square root of g to the 5th. All right, last thing that we're going to talk about. We introduced this idea of problem solving and the steps that you need to do for every single problem that you encounter. And the first one is to analyze the problem, read through it carefully, and make a list of what you know and what you don't know. And then the second thing is to solve for that unknown value that you're looking for. And so make a plan to do that and follow through. It's probably a manipulation of some kind of equation usually. And then evaluate your answer. Say, does this sound reasonable to me? Okay? And then the best way to do this is to kind of estimate what that value might be and see if your value is close to it. So we have a problem here. It says, I have 3 gallons of gas left in my car. I get 24 miles per gallon of gas with my car. I put 7 gallons of gas in my car. How many miles can I drive before filling up again? Okay, so we originally had 3 gallons of gas, and then we added 7 more. So we know that our initial amount of gas is going to be 10 gallons. Okay. And we're also given this value, this equality in a way that for this vehicle, 24 miles will be covered using 1 gallon of gas. Okay, so now I've analyzed the problems, I've listed my knowns, and the unknown is how many miles can I drive before I run out of gas? Well, I have 10 gallons of gas, and with one of those gallons, I'll go 24 miles. So 24 times by 10 is 240 miles. Okay, and then ask yourself, does this sound reasonable? And even think back to items in your life, and when you look at your vehicle and you're filling up with gas there, and how far generally you can travel, and just again look at the problem and say, is this a reasonable answer, or is it unreasonable that I make a mistake that I need to go back through and look? And then the last thing that you need to cover in your notes is a second problem similar to this, talking about heartbeats and how many heartbeats in an hour versus a day. And I want you to take some time and give that a go at home. Let me know if you have any questions at all, and I will see you in class next time.